Well, hey folks, welcome back to another Timber Talk Tuesday. I'm Ricky McLean with WoodWorks. Now, I get asked pretty often by young engineers and architects, as well as by students, how they can get their start in mass timber. Now, each of us that is currently working in mass timber has a unique story, a unique background as to how we got here and how we got our start. And I thought, what better way to explain how others have gotten their start than by sharing some stories. Now, I really want to highlight and emphasize the unique roles that engineers play in mass timber and really lift up young engineers and show the opportunities to them, especially female young engineers. So I'm going to bring into this three-part video series, 3 female engineers, and they're going to share their stories on how they got their start in mass timber, as well as some of the recommendations they have for others looking to get into it. So without further ado, here is Tanya Luthi, Vice President of Structures with Intuitive, based in New York City, Annavitte and Senior Engineer with Thornton Tomasetti, based in Portland, Maine, and Parisa Nassiri, Senior Fire Engineer with Holmes, based in the San Francisco Bay Area.
The biggest lesson that actually we really learned in the last few months on a particular project was that knowing who is sourced or who you are sourcing your mass timber framing from is so important and really critical to know as early as possible in the project. Just because it's not like a steel or concrete product where you can specify a certain design property and you can get it almost anywhere. Every manufacturer has maybe a selection or maybe just one type of product or grade that they are producing, and they're all different. And in America, while they have to adhere to meeting certain minimums for certain grades, in Europe it is a different system. There's different design properties that are coming out of a lot of European manufacturers that are going to be different from what you're seeing from US manufacturers. And it's also species dependent, how the tree grows, what type of tree it is, and how they're manufacturing it into a CLT or glulam product. So I think it's really important to understand what your minimum design values that you can, design bending and shear and deflection calculations to for your products. If you can know that as soon as possible, it's really going to help you in your project to not have to backtrack. And once you finally understand what your final product is going to be.
I think one of the lessons I'm always learning is knowing when to zoom in and when to zoom out. And so I'll try to explain what I mean by that. When you're used to something and you've done it enough times, like say designing a steel or concrete building, you sometimes go on autopilot, right? You don't necessarily stop along the way to zoom out and ask big questions about goals and priorities, right? And maybe if you're the engineer, that's because you think that's the architect's job. So then you get on a timber project and say, for example, the architect gives you a column grid and it's the same grid they had on their last project. And immediately you just start drawing up the options for that grid instead of stopping to ask why, because the why might lead you to a solution that still works for the architects, but also is more efficient for a timber structure. And so I think another way to think about that same idea is, when someone asks you a question, first, make sure they've asked you the right question, because you can give the right answer to the wrong question, and that doesn't really solve anything. So that's kind of the zooming out part. And then the zooming in part is really about sweating the details, particularly when you're a structural engineer on a mass timber building. What happens down there in the weeds really matters. And so I'll take connection design as an example. If you're used to designing in steel and concrete like I was at the start of my career, you think about connections at the end if you think about them at all. And in mass timber, you need to be thinking, sort of in that zoomed in kind of way about the connections from the very beginning, or you might wind up in the end with a design that doesn't work. So, it's not just a matter of, start the project zoomed out and you ask high level questions and then, you sort of zoom in further and further as you go. You really need to find a way to balance the big picture and the little picture all the way through the whole process.
Well, I'm going to look at this from a fire engineer perspective and from a general building design approach rather than the structural design for the building. So from my perspective, and I'm going to point out probably 3 items as the key lessons learned and items to keep in mind. Well, the first one and most important one from the code perspective would be the construction type of the building. Make sure to have the big picture in mind and to understand the client needs, whether is the building designed for maximum flexibility, for example, for the building height, building area, or for example, the program, whether they want to have the maximum assembly space in the building compared to the residential or the commercial occupancies, or will the cost play a more important role for the projects? What are the sustainability goals that they have? And of course, when it comes to mass timber, what is the desired amount of mass timber that they want to have to be exposed in the project, and does the code allow that for the construction type that has been chosen for the project? So in my mind, this is probably one of the very first steps when it comes to designing the mass timber structures, choosing the correct construction type for the building. But aside from that, I wanted to point out 2 other items that are potentially as equally important. And one of them is the AJ involvement. Well, mass timber in some jurisdictions and tall timber in most of the jurisdictions is still a new method of construction. So it's very important to have the AHJs more involved than compared to, for example, the more conventional steel and concrete construction, just to make sure if there is any concern, it can be worked through earlier rather than later, whether it's a design concern for the connections or whether it's a method of construction for example, protection of mass timber during the construction, or if it's, for example, a site access issue. We want to make sure that these are worked through hopefully in the earlier stages before the project gets into the construction. And last but not least would be the unique details that we have in the project. It's not really uncommon to have unique details in the mass timber buildings, and in my mind, this is probably the beauty of the mass timber design, but it also calls for a better and more effective communication between different engineers that are involved in the projects. When you're designing the connections, or for example the curtain walls, which are very common a very common topic in the mass timber design, for the conventional steel or concrete structures, there are lots of previously tested listed assemblies that you can go back and choose, and from the UL directory, for example, you can pick an assembly that works for the projects and go with that. But with the timber design, at least as of today, there is no tested listed assembly that is available, for example, for a curtain wall system. So you need to make sure that you have a design that has input from the structural engineer, the fire engineer, and from the design perspective, but then at the same time it's constructible and it doesn't introduce a risk or a hazard on the site. But most importantly, at the same time, we want to make sure that it meets the code requirements and it is approved by the AHJ. So it's very important that you have a design team that communicates well and coordinates on different details that may not potentially be of a discussion in other steel or concrete construction, but when it comes to timber, they need a more a deeper conversation for these types of details.